I'm so excited for the slightly longer days. I'm so happy the days are slightly longer. Have you been noticing that the sun's up a little bit later each night? Oh, hey, everyone else except us has sun today. Well, based on Joe, you in Horseshoe Bay, and Hans in Alberta. Oh, we have snow here. We just got like a foot. Oh man, y'all are getting all the nice weather out there. Oh. Yeah, that sliver of the moon on Valentine's Day. Oh, it's so nice. So pretty. Welcome everybody. Sorry, I'm getting distracted by chatting about the moon, but it is 3:30 and it's time to get started. I hope you're all having a lovely first day back from the long weekend. For those of you who had the long weekend, we are here in Toronto. We have a brand new foot of snow, which is feeling very festive. And finally, like, winter has arrived. Chris has already got his face shirt on. What is that?
This is the closest I have to the moon, a moon themed.
That's so good. Oh man, I actually have moon t-shirts, but I didn't think to wear them today. You're doing really well.
That's my 2021 objective, is to get a moon themed t-shirt.
Is that your only moon themed t-shirt?
I mostly have stars and things like that, so I need to get onto the moon.
I'll see what we can do about that.
No problem.
So before we jump too far,
I'm not.
I think we should get one though.
This is not Instagram.
So before we jump too far in, today we're talking about observing the moon. And I wanted to quickly mention that we are launching a new observing program. I know I've said this in the past, but now the website is actually available. So if anyone's interested, we're going to be launching this this online observing program following Explore the Moon, which is one of the RASC observing certificates. The program is called The Moon at Noon, which I know only suits people in the Eastern time zone, but we mean for you to join us over your lunch break if you have it, or your mid-morning coffee, depending on where you are in the world. We'll be going through all of the different phases of the moon and what you can see on each phase while following the observing program. And by the end of it, anyone's allowed to join on Zoom or on YouTube, but by the end of it, you will be able, if you are a RASC member, you'll be able to apply for your Explore the Moon certificate, either a binocular one or a telescope one, depending on which tool you use. The telescope one comes with a pin. The binocular one does not. So I recommend, if you have a telescope, use your telescope. It's going to be great. We're really excited. It's running from April 1st until June 17th, the week after the annular solar eclipse, which is on June 10th. It starts on April 1st at noon Eastern time. Each session is only a half hour long. We're keeping it moving quickly. And we're going to talk a little bit about, in addition to the observing targets, just sort of the basics of observing the moon, and some of the interesting events that have happened at specific sites that we'll be seeing that week. So that will be April 1st. Not a joke. Starting at noon.
So we're gonna give everybody a huge head start.
Yes, this is going to help so much. And so if you're here and you're enjoying it, you're already like 5 steps ahead of the folks who will be joining fresh on the moon at noon in April. So let's get started with all those tips and tricks for observing the moon.
So what I have planned to approach this as is give you a little bit on kind of the moon's orbit and the way that the orbit impacts things like the phases and some of the other phenomenon that causes the moon. But I'm not going to get bogged down into facts and figures about the moon size and mass and all of those things. I mean, we could spend multiple sessions on all kinds of things like that. And then I want to get into phenomenon associated with the moon. So things like blue moons and harvest moons and what they mean and how they work. And then we'll get into a rundown of day by day, what to see on the moon every day. So preview, spoiler alert.
You're gonna totally.
And I'm going to use, instead of using Stellarium, I'm going to use a different program, because this program, while Stellarium is fantastic for everything we've done so far, it's not as good for the moon. So let me just bring up the moon here and bring up my screen. Because this program called Starry Night is much more expensive. In other words, you have to pay for it as opposed to the free stellarium. But it has a more detailed moon map, and it has the ability to independently label features on the moon and outline them and things like that. That stellarium does a bit of it, but it's not as powerful as this software is. So I thought I'd run through that. So to begin with, I mean, I'm not showing too much here at the moment, but let's just talk in general about the moon. So the moon goes around the Earth. The moon orbits the Earth every 27.321 days. And that's called a sidereal orbit. That means that when the moon has completed that trip, it's actually in the same, basically among the same stars. It's sort of pointing in the same direction in space, in the sky. And that means that the moon is constantly in motion as it's doing this trip around the Earth. And it's always traveling towards the east. And that means in the northern hemisphere, that means the moon is always moving steadily and slowly from right to left.
Compared to the background stars.
Yeah. But on top and superimposed on that is the Earth's rotation that brings the whole sky the other direction. So don't confuse the two. So we have things rising in the east and setting in the west. Everything does that. But at the same time, things are moving, planets and the moon are moving as the Earth rotates underneath them. And so the moon actually rotates, travels at night through the stars. So what I'm going to do is I'm going to darken this up. I'm just going to center on the moon here. And I'm going to darken this up a little bit and just sort of prove it to you. Okay. Okay. So if I were to say put a pin on this, the bottom of the V of Pisces, this constellation Pisces, and I'll just zoom in a little more here. Actually, I'll use a different star. I'll use this star because it's more in the middle of the view here. So if I advance minute by minute, you can see that the moon is actually slowly rising, moving farther away from this star here. So it's basically the moon is traveling along the ecliptic. And the way the sky works is that at the moment, west is down and east is up. So I know it's a bit confusing.
Oh, no.
But if you're looking east or you're looking west, then east is, west is down, east is up. If you're looking north or south, then they're left and right. So the way the sky rotates makes a difference. But yeah, if you magnify it, center on the moon here and magnify it and just set it to running, then you can see that it's actually traveling compared to the stars surrounding it. And that'll create some cool effects that we can talk about later, things like lunar occultations, things like that. So the moon actually moves through the stars at, I figured it out, it was about 1.1 moon diameter per hour. So that means if you go out in the early evening and compare the moon to the stars near it, come out an hour or two later, you should notice already in one evening, in the course of a few hours, that it's moved around. That average of 1.1 moon diameters per hour is just an average because the moon has an elliptical orbit. And when the moon is closer to the Earth, it moves faster, as Kepler's laws of motion work. And when it's farther, it moves slower. So there are times of the month when the moon is drifting slower through the stars and faster through the stars. But the average is about 1.1 moon rotation every hour. Now, 27.3 days to go around the Earth. At the same time, the moon is rotating on its axis once every 27.321 days. So if you were able to step back, you've seen pictures of the spacecraft taking video of the Earth and moon together, and you can see the moon is turning as it goes around the Earth. So the spacecraft will actually see all the sides of the moon if it's viewed off the Earth. It's only from the Earth that we only get to see the one side that faces us the whole time. And that's because of a process called tidal locking. And I'll get into tides a little bit as we go down.
Before we move on, Marie-Claude has a question about the position or the relative motion of the moon compared to background stars, which is at its different points in its orbit as it's closer and further away from Earth. Is it actually moving faster, or is it just moving faster from our perspective?
Well, kind of both. So if you calculate, the moon has got a speed to it in its orbit. It's kind of like on a racetrack around the Earth. And literally it speeds up when it's closer to the Earth, and literally it slows down when it's farther from the Earth.
On like the sides of the oval that are longer, and slows down on the sides of the oval of its orbit that are shorter.
Yeah, well, the if you think of an egg-shaped orbit,
Yeah.
the long edges of the orbit would be kind of the average speed, but then it really slows down when it's far from the Earth, and it really speeds up when it's close to the Earth. That's true of any object that's in orbit around another object. It's one of Kepler's laws of motion. That's the same reason why Earth's 4 seasons are not all equal length.
Huh.
Yeah.
That's cool.
So Earth is at perihelion, closest to the sun, in January, which means winter is shorter than summer.
Huh. Interesting. Well, that's nice for those of us with seasonal depression. I mean, it's like probably a day, or maybe less than a day even, but still.
So the other outshoot of all this that I'm talking about, let me just put this away for a second here, is that, so if you put the moon in a telescope or look at it in binoculars and you watch it for a while, you can see that it's moving compared to the stars. But of course, night after night, the moon moves across the sky because it's just completing its orbit. It's got to do 360 degrees in 27 days. And so every night it jumps about 13 degrees. So more than your fist diameter, night to night. So here's tonight, February 16, and then 17, 18, 19. So the moon is actually, in this case, it seems to be climbing higher because it's actually increasing its angular distance from the sun. So let's just wind back a few days here and make this a bit easier to understand. So I'm going to set the time back a little earlier. So when the moon begins its cycle,
I was just going to say, I feel like orbital motion is one of those things that either your brain thinks that way or it doesn't think that way. And you can sometimes, for me anyway, sometimes I can like kind of understand it for a minute or two, but if I stop thinking about it, it's like I've never learned it.
Yeah. It's really extra complicated by the fact that we're observing from an Earth that's spinning.
Yeah.
Like it superimposes that rise in the east, set in the west motion to everything. Plus, the other thing is that the Earth is orbiting the sun. And so when I said that the moon does a trip around the Earth and comes back to the same, basically among the same stars in 27 days, it's not the period of the cycles of the moon's phases is actually a couple days shorter than that. The phases take longer than that because the Earth is moving around the sun. So in the time it took the moon to go around the Earth once, about a month, the Earth's done a 12th of its trip around the sun. So it's actually changing the stars that are in the background of that trip, if you want to think of it that way. Yeah. Yeah. So we don't need, as I say, we don't need to get bogged down too much in all of this, but I just trying to explain that there's 2 cycles going on here. One is that the moon goes around the Earth, and the other is that the moon's appearance changes because of its angle from the sun.
Right.
And they're 2 different cycles only because the Earth is also moving at the same time around the sun. So everybody's learned about phases in school. We don't need to really belabor it too much, but I just want to reinforce a couple of points. So obviously the appearance of the moon and the amount that it's illuminated is dictated by its angle away from the sun and by the fact that the sun is shining on a sphere, right? And there's a couple of cool things about that. So when the moon is at its first quarter phase or third quarter phase, and the sun is shining at it from the side, the boundary between the lit hemisphere and the dark hemisphere is a straight line. That's the terminator line. We call that the terminator. On the days on either side of that first and third quarter, the terminator has a curve to it. And if you can do an experiment at home in the bathroom with a flashlight and a ball, and you can prove that the moon is a ball because of the terminator being curved and then straight and then curving the other way.
Well, there we go. So at the very least, the moon is not flat. Sorry, I shouldn't make jokes like
That's
that on an astronomy show.
That's right. Yeah. The other thing to think about is that, and people, I think people get confused because they don't give this enough thought, but everybody on the planet sees the moon's phase the same.
Yeah.
So
it's always going to be, we're always looking at the same moon, no matter where you are.
Yeah. So that's sort of reassuring that it's the same everywhere. The only difference is that if you live in the southern hemisphere, the moon for you is upside down.
Right. That's fair.
What we're used to. For them, it's upside down for what we're used to.
Mm-hmm.
So the man in the moon, Wilma Flintstone pictures look different when they're upside down. And they actually interpret the pattern of the light and dark areas in the moon in the Maori culture to be a woman holding a water gourd and being pulled up into the sky. And she's holding onto a tree to stop her from coming up. So if you turn the moon upside down, I mean, we could do this another day. We could do a story on that, and I could point that out.
That's very cool.
But it's interesting.
I have a question about craters and shadows, because you were talking about the Terminator. This is from John. Do the directions of the shadows in the craters on the moon tell you anything about where the Earth and moon are in their orbits, or what season it is? I guess saying here on Earth. I don't think so, eh?
Right. So the next point is that the moon phases have nothing to do with Earthlings, right? So just because the moon is full and we're used to seeing the full moon rise at sunset, it doesn't mean that's happening for us. It's happening for somebody somewhere on the planet. But the moon phases occur regardless of what direction the Earth is facing the moon. I know that's a little bit tricky to think about.
Right. It's basically just sunset on the moon, and there's no respect, like just because we're observing it doesn't make it much of a difference, eh?
Yeah. So the question is, the seasons are an Earth-Sun phenomenon, and the moon is little affected by that. There's only one aspect of the moon that's affected by that, and that's this. The moon and the sun are on the sun is on the ecliptic line, and the moon's orbit is not far off the ecliptic line. It's about 5 degrees off from that line. And that causes the moon to sort of rise and fall by about 5 degrees as it goes around the Earth. It's a bit like the horses on a carousel as they rise and fall. And that rise and fall away from the ecliptic is the reason why we don't get solar eclipses and lunar eclipses every month.
Mm-hmm.
Because they only occur at the times when it's synchronized so that the moon happens to be on the ecliptic while the sun is there also, or within a half a degree or so. But the other thing is that because the sun and the moon are sort of on the same plane, if the sun is high in the noontime sky in the summer, then when it becomes time for the moon to come up, because the sun is so high, now the moon's going to be low because it's sort of in the bottom of the teeter-totter, if you want to think of it that way. The ecliptic is tilted off the Earth's equator. And so if one object on the ecliptic is high above the equator, the other is going to be low, below the equator. So the celestial equator for us is an arc about 40 degrees across the sky. That's always there. So the moon in the winter, when it's full, shines high in the sky, and it casts shadows similar to the summer noonday sun. So if you have a gazebo in your yard or something like that, you could match it up. It would look about the same. So that's how you could tell what season it is, because how high is the moon climb at night? If it's low, then it means it must be summer, and if it's high, it means it must be winter.
Right. Okay.
In between. But other than that, there's no.
In terms of what the moon actually looks like, you can't tell.
No, but you can tell. I mean, you can tell where the sun is from the moon's shadows, the angles. You can do geometry and trigonometry, and you can figure out where the sun would be.
You can also figure
we're
out.
going to come to that.
Wait, and you can figure out how deep craters are by doing math.
Yeah.
Everyone's favorite subject.
2 more things about phases, and then we'll move on. So when the moon is filling with light after new for the 2 weeks following new moon towards full, it's waxing. So waxing means adding. And then after full moon, it's starting to empty of light. That's waning. And in the first week after new, while it's waxing, when the terminator is curved towards the sun, that's crescent. You know, it's got horns. And after the first week, after the first quarter moon, then the moon gets more than 50% illuminated, and that's called gibbous. So,
Right.
so the moon can be waxing or waning, and it can be gibbous or crescent, and they're combined.
It goes waxing crescent, waxing gibbous, waning gibbous, waning crescent.
Waxing crescent, waxing gibbous, waning crescent. Is that what you said?
Yes, I think so. Yeah.
Good. Okay, one more thing. So the moon, we have something called a lunar month. So the moon's cycle of its phases produces a lunar month. But the lunar month being, what did I say it was? 29 and a half days, is different from our calendar months, right? We have February, which is 28 days, and then we have the other months, which are 30 or 31 days. They don't synchronize with the moon. So the cultures that use a lunar calendar, their calendars don't synchronize with our Gregorian Western calendar, because they work on when the new moon or when the full moon occurs within each month, and that's where they anchor their timekeeping to. So that means that long months like March and so on can actually have 5 phases of the moon in a month. So if the first phase of the moon, the first quarter, full, last quarter, new, happens within the first day or 2 of the month, then it can repeat at the very end of the month. So that's why you get blue moons.
Right.
But you
Yeah.
can have a full moon in the first day or 2 of a month, and then another full moon at the end. That's a blue moon. February can never have a blue moon if that's
It's mathematically impossible.
Yeah, because the phases won't repeat fast enough. In fact, February often skips a phase, so you only get 3 in a month. Let's see. Okay, so I talked about orbital inclination. So the moon, the sun is on the ecliptic. Let's see if I can bring this up here. Bring the sun, and I'll draw the ecliptic on here. There you go. So I don't know if you can see it very easily, but there's the path that the sun takes through the sky. And then where's my moon gone here? And then I'll put the moon's orbit on here if I can do the moon. Just show the difference. The moon's orbit is here. So you can see that they're parallel, but they actually diverge and converge. So you can see over here, the two circles intersect. So if the sun happened to be here and the moon got there too, then you'd get an eclipse. But because the moon and the sun are both 1/2 degree in diameter, if they're more than a 1/2 degree apart, they're center to center, then they miss each other, then you don't get an eclipse. So that's why.
Are you going to talk about apogee and perigee and what happens then?
I am.
Okay, I'll leave it then.
Right. So the fact that the moon rides up and down compared to the ecliptic means that sometimes we're actually able to look over the top of the moon a little bit or under the bottom of the moon a little bit. And that's called libration. I'm going to bring up a diagram that shows libration. Let's see if this will work.
Mike, I hope I knew libration was coming. Mike's been asking about libration for a few minutes, and I've just been not saying anything because I knew we were going to get to it.
put on some meditative music and watch the moon.
Oh,
so if you were able to take away the daylight and take away the Earth's horizon and just stare at the moon for a month, then you'd get this pattern. So you can see that the moon, the phases are traveling through from right to left. And at the same time, the moon is nodding up and down a little bit. And that's that riding up and down like the horse on the carousel. And it's also actually tilting left and right a little bit too. So the up, down, and the left, right effects are called libration. And they allow us to peek over the top a little bit, peek underneath a little bit, and to peek on left and right a little bit. And the reason that it happens left and right is because of that elliptical orbit that the Earth, that the moon is operating under. There are times when it's traveling faster or slower than the rate it's also turning. So it actually gets ahead of itself a little bit or it gets behind itself a little bit. And so we can see one edge or the other. And so if you were to study the moon through its cycles of libration, you could actually eventually see about almost 60% of the moon's surface from Earth by waiting for those times when those edges were shown.
I don't think I have I don't have my observer's handbook here, but the libration is in the observer's handbook. It's the little dots around the moon drawings each month in the sky this month. You'll see the little dot, which will tell you which way it's librating. Is that a verb?
Librating, yeah.
Cool.
So because of that elliptical orbit we talked about, it also means the moon varies in its distance from the Earth. And that variation runs about, let's see, between 405,000 kilometers to about 362,000 kilometers. So that you can see that it's apogee when it's farthest from the Earth and perigee when it's closest to the Earth. That means that the moon will look bigger and smaller depending on whether it's at apogee or perigee. And this is where the idea of supermoons and mini moons come from. So I said that the moon's distance from us varies on the orbital period of the 27.321 day period, but the moon's full to new and back again cycle is the 29.5 day period. And about every 14 months or so, if I got this right, they synchronize. And then you'll get 3 or 4 months in a row where the moon is full when it's close. And those are the supermoons. And supermoon is not an astronomical term. It was coined by an astrologer in 1979.
Hey.
And the media loves it. And so people use it and it gets people out to look at the moon and we think that's great. So
honestly, as long as people are getting outside, that's all that matters. Also, shout out to my failure to change the Zoom email yet again. And someone pointing it out being like, you said you were talking about astrology.
Astrology.
Sure? You're
so
right.
We did.
I did.
So
we did. We talked about it.
Now, I also mentioned this during the astrology session, that the astronomical term for supermoon is a lunar perigee syzygy.
Syzygy, my favorite word in the, well, I guess it's.
Syzygy is when 3 objects align. And so the moon being lunar, perigee when it's closest and lining up with the sun and the earth, that's a supermoon. Lunar perigee syzygy. The definition of supermoon, if you can have a definition by a phrase coined by an astrologer, sure, is when the moon is within 90% of perigee or its closest approach. And this year, now, if you want, folks want to get your notebooks out, I'm going to give you the dates for all the cool events that are going to happen with the moon this year. So the supermoons this year are going to happen on April 27, May 26th, and that'll be the largest moon of the year.
Ooh.
So it'll be closest to perigee on that date, on that full moon. And that will also be a total lunar eclipse.
Ooh.
So that'll be a blood supermoon, blah, 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 blah. Right? And the last of the cycle of supermoons is June 24.
Okay.
So let's see if I can quickly bring this up. I'll center the moon and I'll set this to May.
This is, as you get that sorted out, this is one of those areas of science communication that I find really interesting because you have blood moons, which is another way of saying lunar eclipse, which means that the moon sometimes appears red. You have blue moons, which has nothing to do with the color of the moon. It's in fact something else entirely, that there are 2 moons in 1 month or 4 moons in a season. And so then you get people going outside going blue blood moons and which color? Purple? And in fact, only 50% of things have, only the blood part has anything to do with the color. And oh man.
So this view I'm showing right now is the moon on the morning of May 26th. So it's going to be about, when a supermoon is about 14% bigger than the opposite, which would be a mini moon. So a full moon that happens at apogee, you could call it a mini moon if you wanted to. So that the difference, somebody said, the difference would be like holding a loonie and a toonie at arm's length, the difference in size.
Oh, wow.
Or maybe it's a 14-inch pizza versus a 16-inch pizza. It's something like that. So go ahead.
That makes a big difference when it comes to pizza, but visually not a huge difference.
So this is the moon, the full moon on May 26th. You can see that the moon's orbit is near the point where it converges with the ecliptic. So the ecliptic is the upper line here, and the moon's orbit is the lower line. So when the moon is within, half degree or something of the ecliptic, then it'll obscure the sun if it's a solar eclipse, but it'll dip into the Earth's shadow if it's a lunar eclipse. So the sun is opposite the moon in the sky, which means at this point, the Earth is in the way of the two. And so the Earth is casting a shadow in space, and the moon dips into that shadow and produces the lunar eclipse. I'll actually go into a bit more detail about the circumstances of these eclipses in a little bit. So let's go back to now. Talk about when you can see what. So in general, to do with the moon phases. So at new moon, we cannot see the moon for a day or so because it's hidden beside the sun. It's closer to us than the sun is, but the sunlight's only shining on the hemisphere of the moon that's facing away from us. So the hemisphere facing towards Earth is not illuminated. And besides, you've got the glare of the sun, so you can't see.
Can I tell a very short, funny story?
Sure.
Last year, we were volunteering with a group that will remain nameless, and it was an event for Lunar New Year. And they were like, "Can you do some lunar observing?" And I was like, "No, we can't. It's the new year. It's a lunar new year. There's a new moon. It's not possible."
Yeah. So technically speaking, the only time you can ever see a new moon, solar eclipse.
True. Technically speaking, you're right. Yeah.
Huh. So following the new moon, we get about a week where the moon is approaching its first quarter. So first quarter means it's completed 1/4 of its orbit around the Earth. And at that time, the angle between the moon, the Earth, and the sun is about 90 degrees. And so we see the moon half illuminated from the right or from the west, from Earth west. But on the moon, it's the moon's east.
Oh, no.
So don't panic. Just think of it like this. When you look at the moon, think about looking at a map you're looking at a map. And on a map, east is always on your right. So on the moon, the moon's east is always on your right.
And if you were on Earth looking at your map and your head was pointing north, east would also be on your right.
Yeah.
If you're looking down. Yeah.
Yeah. So then the other way of thinking about it is that terminator line. Anybody standing anywhere on that terminator line would see the sun rise on the moon. That's the point where the sun is clearing the horizon for someone standing on the moon. And so the sun is coming at the moon from its eastern horizon. So by definition, east on a planet is where the sun rises.
Okay. Okay, sorry. This is me diving into not this topic, but what about on Venus?
Yeah, so Venus is upside down. Okay. So that means the east and west are flipped.
Okay. So is it still east when it's rising? Wherever the sun is rising, is it still east on Venus?
Yeah, but it would rise in the other direction on Venus.
Okay. Okay. All right. Okay. Yeah. I don't want to dive too far into that because Venus is confusing.
It's just a human convention that we decided that
the sun rises in the east.
That we decided that north would be up compared to the plane of the solar system and the rotation of the star. This is applicable for exoplanets too. Huh. And that east would be by definition where the sun would rise.
Interesting. Okay. Yeah. So if, let's say you had a solar system, or sorry, a stellar system that was that would orbit clockwise, East would be on the opposite side. All the planets orbit clockwise instead.
Yep.
Cool.
Yeah. But by, probably, I imagine that by definition, we would just decide that north would be down in that case. And so it flips it around. And from your local point of view, it would all work.
True. Good point.
Yeah. All right. So first quarter moon is the first week after new. That's the moon that's in the evening sky. It rises in the afternoon. You could even get your telescope out in the afternoon and look at the moon after lunch. And then you've got until about midnight to take a look at the moon when it gets to first quarter. Following that week, the moon is now gibbous and it's heading towards full moon. And that moon is rising later and later each day. By the time you get to full moon, you've got the moon rising. The full moon rises at sunset, sets at sunrise, so it's opposite the sun. Okay. So that moon, the full moon will be, you won't see it until the sun goes down, and then it's up all night. Okay, after full, then the moon is rising even later, and in the post-midnight period, and it's heading towards finishing 3/4 of its trip around the Earth. And when it reaches that completes that third quarter, then it's rising at midnight and then staying visible during the morning daytime, setting around lunchtime. So if you see the moon in the morning sky, it'll always be illuminated on the left towards the sun. And you can do it that way. And actually the objects that you can observe in the evening as the moon is waxing, you can look at those same objects in the morning as it's waning, if you want to.
Think they look slightly different, but they're still there. Yeah.
And then of course that final quarter of the orbit is when it heads towards new moon, and you're really only going to see we call it the old crescent moon, a few hours before sunrise in the eastern sky, before it disappears at new again.
Because it rises just before the sun does.
So that has implications for teachers that are teaching students about the moon. If they wanted to have an exercise where the students needed to observe the moon every day kind of thing, they have to recognize that that's only possible for part of the month. So there are going to be parts of the month where you're up in the evening, and then there are parts of the month where you have to set your alarm clock and get up in the morning because the moon is not visible. All right. The moon only reflects about 13% of the sun's light.
That's really not as much as you'd expect. It looks like it's a lot brighter than that.
That's about the same as an asphalt driveway.
Ha!
Yeah. Now, when we're looking at the moon, let's go back to, what have I got here? Let's go back to now. Let's just zoom in on the moon tonight. So when you're looking at the moon, everybody's heard this before, of course. You're seeing light and dark patches on the moon. And there are two causes of that brightness difference. One is the geology, the rock type, and the other is shadows. So bright things being lit and then dark things being in shadow. And the only time that you can separate that is at full moon when there are no shadows, because the sun is heading straight down from above. And so there's no ability to cast any shadows at that time. So I'm going to jump over here and talk about a couple more things. All right, so I'm going to go my favorites here. And I'm just going to bring up some phenomena. So let's talk about the moon.
We had a question about this on YouTube, so we'll get to it in a minute.
All right. So today we're in the first quarter of week of the lunar month. So we're again in the waxing crescent moon phase. And we're probably a day or two past it, but the thing you can look for at this time of the year is the earth shine. So the earth shine, and just see if I can make that happen in this program.
As you pull that up, I'll just quickly address the question, which is from Mark, who says, when is the best time to see earth shine? Phase, time of year, time of day. Time of day, it will always be right after sunset or a few minutes after sunset. And then phase is always early, like just after new moon.
A day or two after new. And it's a day or two after new moon in the evening, and you can also see it a day or two before new moon in the morning.
Cool. Okay.
And it's especially good in April and May in the evening, because that's when the ecliptic and the moon's orbit is more vertical.
Right.
And so you're getting that nice effect.
Okay.
And the cause of Earth shine is sunlight reflecting off the Earth and heading back and illuminating the dark section of the moon. So the Earth's clouds, or maybe the Pacific Ocean, very reflective, can send that sunlight back and slightly illuminate the unlit hemisphere of the moon. Some people call it the Da Vinci glow. I think Da Vinci may have been someone to note it in the past. Ashen glow is another phrase, and the old moon in the new moon's arms.
Huh. That's
Is another
cute.
phrase. Yeah.
I like that.
So that's a phenomenon you can see around now, or we may have just gotten past it.
Yeah.
Another phenomenon on the moon that you can see on the moon is something called the Lunar X. So there's a phenomenon called pareidolia, where humans have the tendency to make patterns out of things. And there's a point near first quarter, a few times a year, where the angle of the sun is such that it illuminates the edges of a few craters, and they appear to form an X. It lasts a few hours. And when that happens, there's also a lunar V and a lunar L, and I'll show you where they are in a little bit. For people that want to know about the Lunar X, this year it's going to be one on March 20th, starting around 7 p.m. There's going to be one on May 18th, starting around 8 p.m. And there's going to be one on November 11th, starting around 8 p.m. And they'll vary. The visibility varies across Canada because they happen at those times they gave were Eastern Standard Time, so you need to convert for your time zone.
Mm-hmm.
You can actually cut and paste. Feel free to cut and paste any of these times.
Is that in the notes? I didn't realize that was in the notes.
Into your chat if you want to.
I will also add that the only reason I've ever seen the Lunar X is because of Chris, who texted me at 9 p.m. and was like, just a heads up, there's a Lunar X. And I was like, no, I want to sleep. And I dragged my telescope out and I saw it, and it was an excellent night. There it is, in case anyone can see my screen. You can see it right. Oh, come back. Right there. Wow.
Yes. Excellent.
Good day.
So on Thursday night, so Thursday afternoon is the Mars Perseverance rover landing time. Fingers crossed.
Hopefully all is well there.
Thursday night, the Ontario Science Center is doing a virtual star party. I'm going to help with them on that. And Thursday night, if you head outside, if you have clear skies, the moon will be beautiful right close to Mars.
Oh.
So that brings me up to lunar conjunctions. The next sort of phenomenon the moon does is when it's in conjunction with bright planets. And a conjunction technically means they share the same right ascension or east-west coordinate, but we don't care. It's just when they're near each other in the sky. We call it a grouping or an appulse or a conjunction. And there's some good ones this year. So we have the moon and Mars. So because the moon is traveling along not on the ecliptic, but not far from the ecliptic, and the planets are near there too, then the moon actually passes them by every month, every lunar month. So remember when we were talking about Jupiter and Saturn in the fall, and we would constantly be saying, on this particular night, the moon will be there too. And then a month later, the moon will be there too. And those will be photo ops when the three things are together. So Mars is getting a little dim, but Mars is going to be in our western sky for the next few months as it sort of fades from prominence. And the moon's going to visit it Thursday night, February 18th, March 19th, April 16th, 17th, where it's going to hop past it, May 15th, and then June 13th. So roughly 1 month minus a day is usually the pattern, because the way the moon cycle compares to the calendar. May 12th, you're going to have a beautiful crescent moon near Venus in the evening sky. We're going to have a gorgeous crescent moon near Mercury on the 13th. So Mercury, Venus are going to be near one another in the sky on May 13th. I could probably show it. Let me just center this up and go May 13th. May 13, and I'll just make this a little bit later. So you can see there's Venus down here, and there's Mercury, and there's the moon. So they're going to be sort of make a neat photo op in the sky. Let's see, anything else? And then in the fall, sort of August through December, the moon and Venus will meet up again a number of times. Okay, another fun thing that you can do with the moon is International Space Station transits of the moon.
Oh, those are so cool. I've always wanted to see that.
When the geometry is exactly right, the International Space Station will cross in front of the moon. If it crosses the middle of the moon, it takes about 3 seconds. Well, 1 steamboat, 2 steamboat, 3 steamboat.
Even still, that feels like it's a long time.
Yeah. So you want to use video. What you do is you want to use video for that. And you want to, and when it just sort of skims not through the center, it's even shorter. So it might even be as little as a half second. So what I gave you, Jenna, is a note that on February 26th, let me see if I can do this here. February 26th. And again, you have to be on a very narrow track to see it. So you need to use a website to find it. Let's see if I can find the space station here. Okay. There we go. Label this. Center it.
I just sent the link out to that.
At about 5:48, I think that's in the morning. 5:48. So let's see if I can get this to come up with the space station. Here we go. So I can see that there's the moon, and there's the International Space Station. And if I play time forward, oh, it's gone. I missed it. I'll go back a second. There we go. It says the Crew Dragon's capsule will be there too. I don't know if that's accurate or not.
Yeah, it looks like it's approaching it, huh? Or maybe leaving.
So there it goes. Takes about 3 seconds to go across.
Crazy.
So it's possible to photograph that. If you Google it, you can find examples where people photographed it. Yeah. So if we open up the Finder, open. See if this comes up. So you go here. You type in. You can use the auto detect for your GPS, or you can select from a map, and you can say, if you're willing to drive and if you're not locked down, you can say, okay, in this range of dates from, this has got Feb 20 to March 18, calculate. And this will actually give you the sun and the moon. So you can see that on my location on March 28th, the ISS will skim the sun. And on February 26th, that's the moon one we just looked at. And if you show on map, it'll show you the path where that's visible.
That's incredible. That's such a narrow path.
Yeah. Yeah, the moon's, the geometry, because we live in a 3-dimensional universe, so any little north or south deviation will cause it to miss.
That's crazy.
Yeah, so that's the moon one. And then the sun one. So there's the sun one, goes right through Eastern Toronto. And you can actually recalculate for this location and show it. And there, so it takes, what does it say? It should again be about 3 seconds to go past. So there's a fun tool people can use. It doesn't matter where you live. You can use that anywhere and look ahead to see if you can catch such a thing. All right, let's talk a little bit about eclipses.
Before we go to eclipses, sorry, there's a question from someone in the chat. I'm gonna have to go backwards about our previous topic, which was lunar conjunctions-ish, whatever, close to the same area as the moon. Could you get repeat conjunctions for planets in retrograde?
Well, the planet can be moving prograde or retrograde, but the moon just comes back every month. Generally, the moon's faster than the planets are moving.
by a lot,
Yeah.
usually.
So, but the prograde retrograde situation can actually cause the moon and a planet to miss one another. So say the moon visits Mercury 1 month, but by the time the moon comes back a month later, the Mercury's left. It's gone back to the other side of the sun. So that sort of rule I said about once every month minus a day, that's true for Mars and Saturn and Jupiter and
The
those
further
planets.
away planets.
And Venus too. But Mercury is tricky because it's doing a lot of moving at the same time.
Mhm.
So there are four eclipses this year happening in 2021. There are 2 lunar and 2 solar eclipses. Let's see, I've got an annular lunar eclipse, which I showed at the beginning. I'll just set it up here. So that one's visible in the Toronto area and across much of Canada. Let's get this one, favorites. And I'm just going to open up the picture, the diagram here for everybody. So there's a great page called Eclipse Wise, and a gentleman named Fred Aspenek runs that site, and he does all the calculation of the eclipses for NASA. And so this is the annular solar eclipse of June 10th, 2021. For us in Toronto, it's going to be visible for a short while after sunrise. But basically the eclipse, so what happens is the moon's shadow being cast onto the Earth will first touch onto the Earth in northern Ontario here. And then as the moon moves in its orbit and as the Earth turns underneath it, then the shadow will run across basically right over the North Pole of Earth and then start heading a bit south into Siberia, and then it'll lift off the Earth. And so that's only the period of time when the eclipse is visible. So for us, it's starts around 4:45 Eastern time to around 6:30 a.m. Eastern time. Maximum will be 5:40 at 5:40 a.m. when the sun will be 80% covered from Toronto. Now this is an annular eclipse, and what that means is that the moon is closer to the Earth, so it's smaller. Something's bigger, it looks bigger. When it's farther, it's smaller. It'll be near apogee where it's smaller, and so it will not be sufficiently large to cover the entire sun. So you get a ring of sunlight around it. That's an annular eclipse. Let's see. Then the next total solar eclipse is going to happen. I'll just close this up. December 4th, but that's across the Antarctic. And it's actually a perigee eclipse. So the moon will be bigger than average, and that means totality is extended.
Ooh.
The moon covers the sun longer. But that one's not really visible for anybody except the penguins. And then there's a lunar eclipse. Let's see, Wednesday, May 26th. That's the one I showed you a little while ago. That one's none of Canada gets to see that one. But on November 19th, then we get a partial eclipse from all of Canada to see it. And that's only partial because the moon's going to dip into the Earth's shadow. Let me bring back the eclipse wise here to show what I mean by that.
I'm doing my best to keep up with the dates in the chat. So I'm hoping that everyone will have this information. I'll do my best. I'll post it in the YouTube video description once we're done as well.
So 2021 November. And here. So the dark circle here is the deep part of Earth's shadow. And you can see that the moon is going to approach. The gray shadow, the gray ring is when the sun is partly blocked by the Earth, but not entirely. So the moon darkens just a little. That's the penumbra. But when the moon enters the dark circle, that's when the sun is completely hidden by the Earth's bulk. And so the moon gets dark and the blood red color comes out. The reason you get the blood red color is because the only sunlight reaching the moon is coming over the Earth's horizon. And what does the sunlight look like at Earth's horizon? Sunset colors, it's red. That's what the red the red colored moon comes from. And if you, I don't know if you can see from this diagram, but just a little tiny bit of the moon will stick out beyond the shadow. So that's why it's considered a partial eclipse and not a total eclipse.
For that reason, astrophotographers out there, it's going to be a trickier one to capture, I would guess, because there's going to be one really, 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 really overexposed spot if you want to get the moon to look red.
Yeah. Let's see, how are we doing here? All right. So I just want to mention one or two more things. So the blue moon we talked about, a blue moon has two definitions. One is the second full moon within a month, and the other is that normally there are 12 or possibly 13 full moons in a year, depending on the way it syncs up. And that means that you can either have 3 full moons in a season or 4. One season gets a spare full moon. And so the more formal definition of blue moon is when you have 4 full moons within a season, and the third of them is usually called the blue moon. And so this year that will be August 22nd.
Okay.
So it doesn't mean there is more than one full moon in August. It just means that between June 21st and September 21st, you'll have 4 full moons instead of 3.
Okay. So, but in theory, there should be a second full moon in at least 1 month, right? Just the way it works out?
Yes, I can't remember though which.
Okay. But the main thing is that it's a blue moon when it's the last of those four moons, or it's the extra full moon in a season. Yeah. The last of the 4.
The third of the 4.
The third of the 4. Okay.
I don't know why they decided to make it the third of the 4.
Why not?
All right. So now I'm going to show the moon's orbit again, and I'm going to show the ecliptic again because I want to talk about the harvest moon, and then we'll get into looking at moon stuff. All right. Let's view the ecliptic. All right. Here we go. So I want to set this to October. So you can see here that at sunset in October, and by the way, this is September, but the full moon, the harvest moon is defined as the full moon closest to the September equinox. And it happens that this year, the equinox is on the 20th, I believe, and the harvest moon is on the same day or the day before. So let's just do this.
I wonder if better astronomers than me have their Google calendars set up for this, but I certainly don't.
Yeah. So the moon is going to be full right around the time of the September equinox, right about here. And just let me bring this up. And what you notice is that, see how flat the moon's orbit is compared to the horizon? It's really a sharp angle. And that means that when the moon does that 13-degree hop along its orbit, it's moving really left-right more than up-down. So around this time of the year, night over night, the moon is moving more this way than this way. And that means that it rises about the same time for several nights in a row. Normally the moon's about an hour different every night, rise time. But around the harvest moon, the moon might be rise as little as 20 minutes delay instead of an hour delay. So what that means is for several nights in a row, you're going to see the moon. If you go for a walk with your dog every night, you'll see the moon. Oh, there's the moon. And then the next night, oh, it's there again. And then, oh, it's there again. Because it's not going to vary in position that much.
Huh. That's kind of cool.
It'll be sliding to the left instead of dropping down. And of course, the harvest in the fields can kick up dust. You can get the moon a golden color. The atmosphere will be filled with dust, so you can get a moon shining through that dust and produce a harvest gold color and that kind of thing. So that's the harvest moon. A couple more things. The phases of the moon affect meteor showers because the moon's cycles are out of sync to our Western calendar, but meteor showers are derived from Earth's orbit around the sun. So meteor showers are locked to our calendar. Then some years you get a full moon ruining a shower, and then maybe the next year you get a new moon and the shower is great. So it varies that way. Let's see. All right, I'm going to skip occultations and things like that. and move on to what to look at. So if you put your telescope on the moon, the rule of thumb is roughly that an 80 millimeter telescope, about a 3-inch telescope, can see things as small as about 1,800 meters or 1.8 kilometers in size on the moon. So that would be pretty big. That's pretty big, right? For a small telescope. A bigger telescope can resolve more detail. So a 6-inch telescope, you can see an object that's about 1 kilometer across. And then an 8-inch telescope, you can see something that's about 800 meters in diameter. I think I saw that in order to see the lunar module, you would need a telescope with a mirror of several hundred kilometers in diameter.
Wow.
So it's just not happening from Earth.
So then I just saw an article recently about this new radio telescope that someone's military developed, which is, sorry, not radio, radar telescope, which bounces, I guess, light off of objects and then retrieves it. And they could see up to 5 meters across on the moon, in theory.
Yeah, because, well, you can also combine radio telescopes that are kilometers apart and make an equivalent of a much bigger telescope. That's how they do it.
Cool.
So I'm just going to draw a circle here on the moon. So there's a circle. So that circle represents about the view of a typical backyard telescope, about 1 degree of sky. Now, think about it for a second. If you've ever observed the Messier objects or deep sky objects or anything like that, and there's maybe a few hundred really cool objects that you're used to looking at with your telescope, imagine that all those objects are all in that circle, or half of that circle on the moon. So when we talk about looking at features on the moon, we have to magnify things so much because we're used to things being way spread out, but on the moon, they're all there in that one little patch of sky. So it's kind of hard to wrap your mind around, but it's why when you do the Observe the Moon certificate from RASC, you find yourself using really high-powered eyepieces a lot because you need to enlarge the moon quite a bit in order to see some of the small features on it.
If you can believe it, we have 3 different observing certificates. There's the 2 Explore the Moon certificates, 1 for binoculars and 1 for telescopes. And then there's the Isabel Williamson Lunar Observing Program, which has like 140 targets or something like that. It's insane.
Yeah. So I'm about halfway through that one.
Good for you, Chris. Oh, man.
But you know, it's tricky because the seeing those small features on the moon require good seeing. And if you're used to looking at the moon in the evening when you're looking at the Earth shine and that kind of thing, the moon is already quite low in the sky. And so you get a lot of turbulence in the view through the telescope. So the moon is nicer and clearer when it's high in the sky. All right, let's sort of march through the days of the month as the moon waxes, the lunar month. So it takes about 14 days to go from new to full and then 14 to go back. A couple more tips for using your telescope on the moon. If you find the moon's really bright when it's full, you can use a neutral density filter, the same filter, you can use either a fixed one or a variable one to dim the moon down. If your telescope has one of those sub-eyepiece, lens caps, where you can have the smaller circle or the big circle, that'll dim the moon and make it more pleasing. You can put sunglasses on.
Yeah, that works too.
If the moon is bright. And like I say, you can use high power. And don't forget that if you're comparing a moon map to the telescope, that your telescope would often flip or mirror image the moon. So that's that.
That part's where I always get confused.
Yeah. All right. So, and you can get the apps like Sky Safari will let you flip the view to match your eyepiece if you want to do that. So when the moon is brand new, so this is the picture of the moon when it's 1 day old. So it's about 5% illuminated. And the Islamic calendar operates by starting their months when they sight the new moon, when it's returned after being new, the first glimpse of it after being new. Nowadays, they use the math to calculate when that will be, but in the old days, they would have somebody whose job was to stand and wait for them to catch a glimpse of the moon when it returned after its new phase. So that can be tough to see. The moon is really low in the sky. I don't know if you can see it here. It's only a few degrees above the sky when it's 1 day old like that. But let's jump ahead a couple days. We'll start looking at some of the things you can see on the moon. So let me just zoom in here. So after about 3 days, the moon's about 10% illuminated, and it's really pretty. That's one of my favorite times to look at it. That's when you might get the Earth shine. And the things that you want to look at on the moon would be like the dark Mercurium. So Mercurium is this dark patch on the moon. It's one of the Mare. And I'm just going to advance a day so you can see it a little bit better. So there's Mercurium. It's actually oval shaped. And we get actually a foreshortened view of it when we're looking at the moon. So Mercurium is a great tool to look at libration. So Mercurium will go closer to the edge and farther from the edge, and it'll go higher to the north and farther to the south, depending on how the moon is librating, wobbling and nodding. So that's a neat one to look at. Inside Mercurium, you can look for craters that are partially submerged. You can see there's sort of a half edge here where the rest of the crater is submerged. That can happen because of subsidence. So the crater may have been complete at one point, but then it collapsed and then flooded with basalt. So the low half got covered over. There's a big crater called Cleomedes that's above Mercurium. That's a neat crater to look at. And then there's a big set of this big chain of craters running down the southern edge of the young moon is really cool as well. And Petavius is neat because Petavius has this mountain in the middle and then a really deep crack or fracture or rill radiating out from it. So you can see that in a backyard telescope. You might even be able to see that kind of detail in good binoculars, but you'll certainly see the big craters in the good binoculars. And of course, when the moon is setting, then these things are sort of tilted downwards. All right, let's center the moon up and let's go ahead to the next day. So day 4, we get a little bit fuller. And on day 4, you're going to get and start be able to see this crater called Proclus, which sits on the edge of Mercurium. And this is the one that's going to have a ray system. So a ray system is produced when something slams into the moon and blasts material out, spreads it across the surface of the moon. And usually it's symmetrical or radiating around the crater, but if the object came in at an angle, it can make the ejecta go only in one direction. Were you going to say something?
No, I was just doing hand gestures because I was excited. But we're gonna in the Moon at Noon, we're actually going to encourage you to all bring trays of flour and cocoa powder so we can do this experiment all together, because we recreated an experiment of making ray systems at the 2019 GA using a kiddie pool full of flour and dropping things from the 3rd floor of the York, one of the York's university's buildings. So we're going to do a mini version in person because we're all getting tired of doing not hands-on stuff.
So around day 5, the moon is about a quarter illuminated, about 26% illuminated. Here you can see that, not if you can see there's sort of a dark wedge here on the left. So that's where the Proclus ejecta is missing. The rest of it is sprayed out on the right here. So the object came in at maybe 15-degree angle with the horizontal horizon of the moon. When it hit, it threw everything in front of it and nothing got dropped behind it. And so you can see that. So that's Proclus. And then down here, this is a Mare called Mare fecunditatis. Yeah, fecundatus. And it's actually got a little pair of craters called Messier. And in a telescope, they look like a comet. Can you see the little streaks here? Yeah. These are more apparent at near full moon. But again, cool. Whatever pair of objects hit the moon came in at maybe just a couple degrees above horizontal and just hit that way and threw this material out front. That's day 5. And by day 5, you can start picking up the really pockmarked, bright colored lunar highlands. So the dark areas are the basalts, the heavy, dark, iron-rich rocks, and the bright areas are the aluminum-rich, bright colored, shiny ornithosite rock. All right, let's jump ahead. Next day. So by day 6 or so, we've got the moon about 40%, 45% illuminated. You can start looking for Mare Tranquillitatis, where Apollo 11 landed. You've got these prominent craters like Theophilus just below it. These are really neat. They've got mountains in the middle of them. We can look for, along the terminator, you can look for situations where you've got a peak in the crater that's lit, and then the rest of the crater is black, is dark. And you can also look on the dark side for a peak that's lit, and it's sticking up above, and it's catching the sun while everything else around it is dark. So you can start looking for situations like that along the terminator. And the terminator actually shifts across the moon even hour by hour. So if you observe early in the evening and then come back, you can see differences. Yeah, Palmer Highlands. Yeah, so we'll go back to the next day, day 7. So we're getting close to first quarter moon, and this is when you might see the Lunar X. So the Lunar X is produced when, on those dates I mentioned, when the edges of these 3 craters get illuminated first by the rising sun, and that produces an X shape that you showed. I have a Lunar X I can show everybody. I'll maybe bring it up in a bit. If you Google Lunar X, you'll certainly see it. So if you see the Lunar X, it lasts about 3 hours, and then it fades from view. And it's located kind of a third of the way up from the southern horn of the moon at first quarter. And then up here, let me just center this up and go ahead a day. I've gone a little past first quarter, but the lunar V is up here. So when you're seeing the X, look above the equator of the moon and see if you can see a V, also produced by this crater Oort. There's also down here, you can see that, actually, I had the wrong craters marked. These craters, see there's sort of a Mickey Mouse face and ears. This is where you get a lunar, the lunar L down here.
Ah.
Yeah. So the Lunar X should be shown in this one, I think. Yeah. Let me just mark on here. May have forgotten to put per back. Yeah. So this is where the Lunar X would be. This is where the L would be, and this is where the V would be around first quarter on those dates that I mentioned earlier. Let's see what else we've got here. So around day 9, so now the moon is gibbous, more than half illuminated. So around day 9, you can start looking for this mountain, this curved mountain range around the edge of this giant Mare Imbrium. And this is basically the just the edge of the basin that got blasted out and built up in a ring and then later filled in. And they call these the Apennine Mountains. One of the Apollo missions was sent near these Apennine Mountains. Then you can also look for the dark patch below the equator of the moon. So let me just zoom back out. So here's the sort of equator of the moon. Below that, there's a dark patch. And that's Mare Nubium. And if you look at higher power, you can see the lunar straight wall.
Oh.
So that's the straight wall. And it's basically a fault. So it's a scarp. And when the sun is shining from the east, you see it. And when the sun is shining from the west, you can also see it.
But when the sun's straight above it, then it just fills the whole.
It sort of disappears at full moon. Yeah.
Yeah.
So you want to look for this a day or two after the first quarter phase. That's called Rupus recta is Latin for straight line, basically, or straight cliff. All right, what else we got? Oh, then we also get Tycho. So Tycho is one of the youngest craters on the moon. It's very prominent. It's the necklace that Wilma Flintstone is wearing. Yeah. And then below that, there's a giant crater, sort of a flat crater called Clavius. So Clavius is famous for 2 things. One, it's the location where the NASA Sophia mission found water molecules,
So cool.
reported finding water molecules in the daytime, daylit or sunlit part of the moon. And it's also the location of the monolith in 2001: A Space Odyssey.
Oh, I didn't know that. That's cool.
Yeah. And it's cool because it has this chain, this curved chain of decreasingly sized craters. So big, smaller, 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 smaller.
There was back when Sophia found that water, there were several media outlets that were like, here's a super easy to find crater on the moon. I think it's one of the hardest to find craters because there's so many other craters in that part of the moon.
But it's really big and it's below Tycho. So that's the...
Okay, fair enough. Yeah.
In fact, like straight south of Tycho. All right, let's move up to next day. How's my time doing? Good.
All good, but I have a question that I really want to answer, which I'm saving for the end.
Oh, really? You want to wait? You want to wait? Okay.
Yeah, because it's not quite about any individual day. So I do want to save enough time to answer it though.
All right. So around this point, the moon is about 3/4 illuminated. And what's great is that we're now getting some of the primo parts of the moon to look at. We're getting the crater Copernicus. So Copernicus is in the sort of above the center of the moon. And it's got everything. So it's got Central Mountain, which you can, if you time it right, you can see the mountain lit, but the rest of the crater dark. Ooh. It's got edges that have slumped, and you've got terraces, so they step down into the crater. It's got a giant ejecta blanket where it blasted material out, and it's got a big slope all around it, almost like a volcano. And then it's got these rays, and the rays where they blasted the material away, but the rays are very raggedy. They're sort of wavy and dark, whereas Tycho have these streaky, straight rays. All these bright lines I'm pointing at are ejecta from Tycho's ray system. And the Tycho's ray system extends for thousands of kilometers across the moon. It was a huge blast relatively recently. So that's that one. And then if you look at the top of the moon, you can find little Plato. So Plato is kind of a mini mare. It's actually considered a crater, I believe, but it's been filled with lava, filled with basalt, and produced this really regular, dark, round, oval shape down above up near the top of the moon. So that's something to look at around this part of the time of the month. And then moving on to 11. Mm-hmm. By the time we get to the day after this, we're starting to fill in more of the Oceanus Procellarum, which is the big dark section on the west side of the moon. But if you look up near the top, this is where you can see the golden handle. So Mare Imbrium is this giant circular basin. And then another large crater on its edge got partially submerged, leaving only part of its rim exposed. And when the sun is at this angle, it shines on the inside of the rim and produces a bright curved shape. And we call that the golden handle. And where it dives underneath, you've got these two peaks. These are called promontories, if you like. And if you have a telescope, you can see that Sinus Iridum, or the Bay of Rainbows, is very flat, really flat. It's only got a few craters in it, but at certain sun angles, there are also some wrinkles in it that you can see. They're called dorsi, or wrinkle ridges. Okay.
Why is that? Why would it have wrinkles?
As the moon swells or cools, it contracts and things can wrinkle up. Various things can happen. Yeah.
We all get wrinkles as we age.
Different phenomenon that can cause it. Mm-hmm. So again, the closer we get to full, the more prominent the ray system around Copernicus becomes. So you can see it's even a bit more clear than it was on the previous day. I'm just going to bring us back to the next day here. Day 12. By the time we get to day 12, the moon is about 92% illuminated. And we're starting to get into the crater Kepler, which is sitting to the west of Copernicus. It's also very prominent. Then up here, we have Aristarchus, and Aristarchus is one of the brightest parts of the moon. And it's actually one of the most tinted in color parts of the moon. The NASA has detected radon element in the moon's crust at that location. So there could be some chemical or some radiation of something that's that's buried in the moon's geology that's producing the extra color and the extra radiation. So that's Aristarchus. And then another cool feature to look for is this really neat crater named Schiller. And Schiller is actually kind of a lozenge shape. And they think that a number of objects hit at the same time. Maybe it was like a chain of a broken up comet or something that came in and boom, 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 boom. And it excavated this one common sort of a trench on the moon. It's really big and prominent. So you can look for Schiller down the lower left edge of the moon here. And oh yeah, this one's cool. So day 13. So when we get to day 13, we're going to see Copernicus, Kepler, and then keep hopping, and you're going to see a bright stain on the moon. So there's a crater named Reiner, and then there's a feature on the moon called the Reiner Gamma Lunar Swirl. And what it is it's kind of a stain. It's all curvy and windy. And it's not different rock type, and it's not produced by shadow. It's because the moon's local magnetic anomaly is so strong there that we think that it protected that patch of the moon from cosmic rays and stopped the moon from darkening. Yeah, so the moon starts out bright when a new crater is made, the moon will be bright. And then over time, it so-called weathers or darkens by the bombardment of cosmic rays and the sun's radiation. But we think that maybe the moon was protected in this local spot by this magnetic field, and it never darkened as much. So
That's
it's called
crazy.
lunar swirl. Yeah. And that's only visible when the moon is close to full or just past full, up in the sort of northwest edge. And finally, let's see what else we've got on the final day here when the moon is full. So we've got another dark small patch called Grimaldi. It's sort of a mirror image to Crisium, except that it's smaller, but it's on the opposite side from Crisium. And the full moon is the best time to see all these rays, all this ejecta that's been spread across the moon. So you can see the streaks from Tycho. You can see Copernicus has them. Here's the one for Proclus. Remember I talked about the Proclus ray system, how it's maybe 200 degrees out of the circle, only towards the east. The Messier rays are stronger.
Oh, that looks very clear, yeah.
Yeah, this is great on telescope. So what was cool is that I used to get booked for star parties on full moons. And of course, you can't look at deep sky objects on full moons. So I figured out all of these neat things that you could see on the moon on full moons. And the Messier crater is a neat one. The other cool thing you can see when the moon is full are extinct volcanoes. So if you look at the center of the moon, just to the east of Nubium, above the lunar straight wall, there's a crater called Alphonsus. And this crater has a triangle of dark stains. And these are extinct volcanoes. That's volcanic ash on the moon's surface. And this is visible, I think, even in strong binoculars, you can see these three dark stains.
That's very cool.
That's neat. And then there's more of those volcanoes up here, way at the top edge. So above the Serenitatis, there's a crater up here called Hercules. And there's some stains. This is Hercules. Hercules has a really bright crater in the floor of it. And then there's the crater to its right, which is Atlas, has two more of the dark volcanic stains. So that's a really great one to look at as well. Those are really obvious in your backyard telescope.
Cool.
One other thing I was going to say, yeah. So I think that was the main thing. Oh, around Copernicus, when the moon is full, you want to zoom in and you can find craters that have dark rings around them. Can you see this? Dark ring, dark ring. So the way that this works is that you've got bright white moon rock that's been flooded with dark basalt. And then Copernicus has come in and punched through that and spread the bright moon rock over the dark rock. And so that you've got a sandwich of bright, dark, bright. And then later on, a smaller object comes in and hits. And it only goes into the dark mare, the dark rock, the basalt. not deep enough to punch right through, and it spreads the dark rock on top of the Copernicus ejecta. So then you get the dark halos on top. You can see there's one there, there's one there, there's one here, there's some over here.
Yeah, it's very cool.
They're all over the place.
Awesome.
So you're reading the moon's geology. It's its history book when you do things like that, and you can see the crater, the terraces I was talking about. When the moon
Oh yeah. On the note of geology and history, I'm going to address Heather's question, which was about are there new craters on the moon? And there are. And I went and did research while Chris was talking. I was listening to Chris, but I was also doing research. For the most part, the only way that we can see new craters on the moon is if they've happened in the past 4 years, because that's the time it's been since we started taking detailed photos of the moon over and over again. And so you can compare them in time, the two photos, and see if there are any new craters. Most new craters are very small. The bigger, I mean, there aren't that many huge craters on the moon anyway, and it's been around for billions of years. Is that an accurate statement? A billion years?
Well, the moon is a few billion years old. I mean, it's
Yeah.
a little younger than the Earth is, but yeah, the craters like Tycho would be, I forget, but it may be 100 million years old, something like
They
that.
are. I looked that up. So Tycho being youngish is only 108 million years old, which is young in geologic time, but not in our time. However, there have been a couple times when we have seen impacts happen on the moon. And then the Lunar Reconnaissance Orbiter has been able to, or whomever has been able to go over and take closer photos. And in the article that I just sent out, they found an 18-meter wide crater, which is pretty cool. And also back in, I think it was the lunar eclipse in 2019 in January.
Yes.
When
yes.
everyone was watching, like everyone had their cameras turned to the moon. And then while it was an eclipse, there was like this little bright boop of light in the middle of the moon. And we actually, like, multiple people managed to capture an impact on the moon at that time, which is really cool.
That's right. Yeah.
That was a good time.
So the solar system is a dynamic place.
It is a dynamic
I'm going to leave you with one last resource here. If you're interested in the moon, there's a cool book called The Cambridge Photographic Moon Atlas. This is a great one. I like this book. There are some downloadable books you can get from NASA. And this is a cool NASA site. It's called the Lunar Visualization Tool. And you can actually use this to dial in an image of the moon visible anywhere on Earth for any hour of the year.
Wow.
So I wanted to prove that the Lunar X is happening on March 20th. So I can go to 3 for March. I can go for 20th. And this is universal time. So actually I want to look at March 20th at 7 p.m. Eastern is 11 p.m. universal time. So that would be 23 update. And can you see the X? It's there.
Oh yeah, cool.
Yeah. And if you sit here and you dial this up, so if I want to go an hour ahead, an hour past this, I need to go 0 and add a day update. And you can see it's there.
Huh, cool.
You can actually advance, you can see it build, peak, and then decline. And if you click on this image, the site will download to your computer a ultra high resolution, I think it's several megabytes in size, annotated moon map, where you can see the exact craters along the terminator labeled. And if you want to, you can go down and get one with the moon upside down. If you're using a Newtonian reflector telescope that flips the moon upside down, then you can get an upside down version to have with you.
So hopefully there was a question about you doing all of the work and downloading all the images from Starry Night with the best craters in them. Hopefully this resource does that for you, dear audience members. You'll have this at your hand, tips of your fingers to download those images. Chris, there was quite a call for people to learn about Starry Night. So maybe sometime we can run a program on Starry Night. What do you think?
Sure. Yep.
Maybe
Absolutely.
we'll get Celestron to sponsor us, because I just found out that it is a Celestron program.
Simulation curriculum. The same people that make Sky Safari, the app, make Starry Night.
Cool.
So, yeah. This is the app that I use in my planetarium, except it's formatted to produce
cool.
immersive view. which is
And
cool.
I did mention this in the chat, but I got a copy of it for free with my new, though not used, new Celestron telescope. So I think some
Yeah.
telescopes
Yeah,
come with it.
I guess what I should have made clear is that Celestron are partners with Simulated Curriculum, and they often sell packages that might include it.
Okay, cool.
You can also paste the resources that I put in the doc into the chat too. If you want to have a good app for the moon with you at the telescope, what I recommend is, as I say, Stellarium Mobile is not as powerful or not as good. Sky Safari 6 is okay, but Lunar Map and Lunar Map HD are good. I think the light is free and the HD is a couple of dollars, but they allow you to like label every single little feature, so you can zoom right in and match whatever your eyepiece is seeing in the telescope.
Awesome. We've hit our 5 o'clock time. We made good use of our time today. We talked about a lot. Do you have any last thoughts before I pitch the show one more time?
No, I just think, make lemonade. If you have to stay home and observe from the driveway, there's lots to see on the moon. And as I said, there are literally hundreds of objects to see on the moon. You would not run out of things to look at, and just gain an appreciation. Download the Isabel Williams certificate, and every little object, they have a cool description of what it's about, what it means, and you can learn a lot about the moon that way.
For sure. And the moon is one of my favorite targets because you can observe it in the city. You do not need dark skies. It can be observed on all the days that you don't want the dark skies, all the days that the moon's up. It's a great target. Everyone can see it. So we have our, if you have more questions, which you do, there have been so many questions and we've done our best to get to all of them. But for the other questions that you've brought up, we will be addressing those in that program. We'll have a little bit more time to do it because it is a 12-week long program with half an hour per week on Thursdays at noon Eastern time, starting April 1st. So that is rask.ca/moon at noon if you're interested. Otherwise, next week, we're talking about, can I remember? Where are we in February? We're talking about religions?
Not yet. That's not till March.
March 2nd is our next one, though. March 2nd will be the next episode, and it's not going to be religions, but it is going to be Messier Marathon. We're doing the Messier Marathon on March 2nd. Cool. We're going to go through a whole bunch of galaxies and how to see them all in a single night. So we will see you all then. And I promise,
I'm just writing an article for Sky News about how to find little galaxies that are hidden behind bright stars. And you don't need to go to a telescope to find them. So
we're going to be talking about that article. I talked to Alendria about this. We're going to be talking about your article. We're going to be talking, we actually have a deal with Sky News to get some online copies. And so we'll be talking about all of that. And I promise I will update the Zoom email this time.
Great.
Maybe, I promise. No, I do. I promise I will. I'll do it. All right. Thanks everyone for joining, and we'll see you all in 2 weeks for our episode on Messier objects and how to see them all. Thank you, Chris.
Up at the moon.
Keep looking